This toy has fascinated me ever since the world of science and engineering has come to my consciousness. TTS motion is almost hypnotic as it seems. Here's how it operates. Wet the bird's beak thoroughly with room temperature water. The opaque container makes it look chilled, but it isn't. Then stand it upright. It'll take a few seconds for it to start drinking. Notice that all of the action right now takes place in the stem here. As it speeds up the action, you see liquid rising and the bird rocking back and forth. If it returned to normal speed, you can see that bird slowly, very slowly, rock forward until it takes a drink, which it will do again and again. In this video I'll detail the bird's clever engineering design, explain how it uses thermodynamics, and link its action to some of the greatest and most impactful devices created by engineers. This toy has a long history, but its current incarnation is due to Miles V. Sullivan, a scientist at Bell Labs. He specialized in methods of manufacturing semiconductors, but as a sideline, invented toys. It's reported that this bird delighted US President Herbert Hoover, an engineer who failed to figure out how it worked, and it also defeated the great scientist Albert Einstein, who spent 3.5 months studying it. It's reported that he refused to take the bird apart. With the benefit of hindsight, let's start by exploring how it works and examining the key engineering design aspects. First, let's ask, is the water ornamental or essential? At first the bird acts just as if the water was still there. Now, let's speed up the bird's motion. You see at 15 minutes it is still drinking. At 30 still drinking. 45 minutes still drinking. 60 minutes still drinking. 75 minutes still drinking. And 5 or 10 minutes later, at 80 or 85 minutes it takes its last drink. The liquid still rises a bit, but it never rises enough to make the bird tip over, which shows that the motion is not perpetual. As long as there is water, the bird keeps drinking. Let's look inside the bird to get an idea of how it works. Underneath the bird's head, beak and fabric covering lies a glass bulb, smaller than the bulb at the base, and also rounder. Now, watch as I put a few drops of isopropyl alcohol in the top bulb to cool it. The liquid rapidly rises to the head. This changes the bird's center of gravity so that it will tilt forward. The head now fills with liquid and then there it drinks. It becomes upright and the liquid drains from the head. Liquid rises again to the head and the bird drinks again. This cycle repeats until all of the isopropyl alcohol on the bird's heat evaporates. Why does the liquid rise? The place to begin is with the bird's manufacture. The bird is filled through this tap, a small pipe built into the head, with methylene chloride dyed red, which is then frozen. A vacuum applied to evacuate the air. The tap sealed and, of course, later hidden by the bird's hat. And then the methylene chloride melts. It turns to liquid and then some of it evaporates, turns into vapor. The key to the bird's operation is that the vapor and the head ending the base are separated by the liquid in the base. It's hard to see, but the tube extends into the base, nearly reaching the bottom. This separates the vapor and base and the vapor in the tube and, of course, the head. So, at rest the pressure in these two spaces are equal, but when the bird's beak is wet, the temperature falls as I'll explain in a moment. The pressure in the head drops below that in the base and the liquid rises. Of course this liquid in the head causes the bird to tilt forward to drink, and when it drinks, the vapor in the head and the base are connected, the pressures nearly equalize. A slug of vapor rises to the top and some liquid drains from the head and then the cycle repeats. To see that pressure equalize, I'll slow down the bird as I tilt it forward. Right now the head is half full. When I tilt it you see a slug of vapor go from bottom to top. I've titled it far enough forward that the liquid in the head is below the top of the tube and the liquid in the base is below the section of the tube that almost reaches the bottom of the bird. This allows the pressure to equalize, and as the bird becomes up, creating the back of the head. If I now turn the bird around you can see that the water has spread to the back. As I continue adding drops on the beak, the saturated area on the back increases. When this water evaporates into the air it removes energy from the bulb as heat. You feel this effect every time you step out of the shower. The evaporating water withdraws energy as heat and chills you. This evaporation, this withdrawal of heat, lowers the temperature and begins the condensation of the vapor, which starts the cycle as I showed you with the cool, compressed gas. As long as the head is wet and heat is withdrawn, From it, the bird will always drink, but if you were to operate the bird in humid air, it would slow down because little water would evaporate, and if the air were at 100% humidity, the bird would stop because no water would evaporate at all. Now, to make this dramatic, condensation happens when the temperature is lowered just slightly. The evaporating water lowers the temperature by only about 0.3 of a degree. The bird's designer choose a highly volatile liquid. This means one whose boiling point is near ambient temperature. Because for small changes in temperature, they engineer this